Uh, Exercise 12.11, 12.11 exam exercises for chapter 12, additional mathematics course for IGCSE and O level. And in this session we will discuss exam exercise, exam problems in IGCSE and O level exams. So let's start with the problem number 1. Find the coordinates of the stationary point on the curve y is equal to x square plus 16 upon x. So we have to find the coordinate of the stationary point. So coordinate of the stationary point on the curve is y is equal to x square plus 16 upon x. So we differentiate this dy by dx, and this is 2x minus 16 upon x square. So for a stationary point we take this dy by dx is equal to 0. So this 2x minus 16 upon x square is equal to 0. So 2x is equal to 16 upon x square. So this x square is multiplied here to get this x cube is equal to 16 upon 2. So x cube is equal to 8, and x is equal to, taking cube root on both sides, x is equal to 2. At x is equal to 2, this value of y becomes, placing the value of 2 here, this y is equal to 12. So the coordinate of the stationary point is 2, 12. So this was the required stationary point, and we have obtained it here. So it's very easy. In the next problem, given that this y is equal to x square upon 2x plus x square, show that dy by dx is equal to kx 2 plus x square, where k is a constant to be found. Where k is a constant to be found. So we have solved this problem number 2. So y is equal to x square upon 2 plus x square, show that this is equal to this, find the value of k. So dy by dx is equal to this, this is u and this is v, so uv. So we have solved, and this is we have obtained as this 2x square 2x and minus x square 2x, 2 plus x square, and this is 4x upon 2 plus x square. So here we have k is equal to 4. So this is k is equal to 4. Here we have a typing error, x square, this x square is here inside as well, which is missing. So this is easy, the curve is this by d by x and otherwise this. So let's start with problem number 5. We have y is equal to 1 over 4x minus 5 power 8, and dy by dx is given as 8 this power 7, 1 over 4x minus 5, and then this value, so this 1 over 4 is here. So this becomes 2 1 over x minus 5 power 7, and x is equal to 12, dy by dx is equal to, so this is dy by dx minus 256. So this is given. This is dy by dx is equal to 256, and we have this incremental change in y, incremental change in y is equal to dy by dx. So this dy by dx is obtained as 256, while the x is varied from x12 to 12 plus p. So this p is the small change, so this p comes here. So this delta y is equal to minus 256 p. This was the required value. Now problem number problem number 8. So we have this y is equal to this. We have calculated dy by dx at some point 2 comma 8, and we have substituted this value and gets the slope. So at problem this we have to find the equation of normal. So this slope is obtained as 2. So the equation of normal, the gradient would be minus 1 over 2. Then this we will place this, and this is 2 and 8 is given. So this is 2 and 8. 2 and 8. So this is but x-axis is equal to y is equal to 0 at a. So this is the equation of normal, but this x-axis cut x-axis, this equation cut at the x-axis where the y is equal to 0 at a. So this becomes a is equal to 18. So this point is where the y is 0 and x is equal to 18 is the a point, and similarly the y is there. So let's read the question again and see. The normal to the curve. This is the curve where we have a normal at the point this cuts the x-axis at a and the y-axis at b. So this curve we have a normal and a and the y-axis at b. Okay, so show that the midpoint of the line AB lies on the line this. The midpoint of the line AB, the line A and B. This coordinates creates a line, and show that the midpoint of the line AB lies on the line this. So this is the required value. So we have this curve, and on this curve at 2 comma 8 we have this dy by dx where the slope is this, and the equation of normal. So the gradient of for normal would be minus 1 over 2. So this is the point, and this is passing through this 2 8. So the equation of normal is given as this, and this normal cuts the x-axis at point A. At point A, this x-axis cutting the x-axis, so where the y is 0. So y is 0 here, so get the value of x is equal to 18. So this a point is 18 0, and this equation also cuts at b where the x is equal to 0. So the y is equal to 9. So these two equations, the midpoint of a and b is given as a. This is a point, this is b point. So a and b, so we get the midpoint as this 9,45. So at 9,45 we see this equation where satisfy this midpoint if it is passing through it. So we see that we put the values here and we get this 18 equal to 6. It shows that this line is passing through this midpoint, which is the given problem that has to show, and it has proved that this satisfied. So this midpoint is passing through, this equation is passing through this midpoint. So let's solve the now problem number 10. This is a rectangular sheet, and this rectangular sheet creates this kind of scoop. A rectangular sheet of metal structure, this 60 centimeters, 45 centimeters. This is x centimeters, and this is x centimeters. This length is x centimeters from here to here. Similarly here, so this curved, and this curves to create this structure. Scoop is made by cutting out squares of side x centimeter from 2/4 of the sheet and folding the remainder as shown. So show that the volume of the scoop is given by this. So we have to show this volume. The A space within this scoop is given by this. Secondly, given that x can vary, if we can vary this x, find the value of x for which v has a stationary value. This volume has a stationary value, we have to find that. So this is the required problem. So this is the this is problem number 10, where this is 45 centimeter, this is here to here, this is x centimeter, this is x centimeter, so we'll subtract it. So this length is 45 minus 2x, and this is 60 centimeters, so this is 60 minus x is equal to, from this to this we have 60 minus x. So show that the v, the centimeter cube of the scoop, is given by this. So this is we have this scoop has this kind of structure. So this is height is x, and this length is 60 minus x, while this length is 45 minus 2x. So 45 minus 2x, 60 minus x, and x, and we'll multiply. This becomes 40, 60, and then this multiply with this one, then this one with this one, and then finally this one. So we have eventually obtained 2700 minus this is 165x, this is towards the square, and then multiply with this one. So this is 2700x minus 165x square plus 2x cube. This was the required volume. So this has proved that this area, this structure gives this kind of volume. So this first part has completed. Now we show that this dv by dx is equal to 2700. So when we differentiate, this is the volume. So we are differentiating with respect to x. So this becomes 2700. This is 165 multiplied by 2. This is 630. This is 4, 3 to the 6 x square. So this is the value. So this for a stationary point, we take this equals to 0. So this is 0. We take our 6 as a common here, and we have obtained this. So this is 45 and 10 is 450. So here we have 45 and 10. So for x is equal to 40, it cannot be vary because the length is already 45. So this cannot be vary. So the remaining part is x is equal to 10. Therefore, x is equal to 10 is the value where we can vary it. X can be 10 centimeters, can be taken, varied. So this was the 11th part. So let's move to the diagram shows an empty container. This is an empty container in the form of an open triangular prism. This is an open triangular prism. This is a shape, and this is open container. This is the open container, the triangular prism. This is the area, space, free space. The diagram shows an empty container in the form of open triangular prism. This is the open area, this is the open area, and this is covered, and the triangular faces are equilateral with the side of x centimeter. This is equilateral, and of x centimeter, the length of each rectangular face is y centimeter. This length is y centimeter. The container is made from this thin sheet metal. When full, the container holds this much volume. This is the volume that this container can contain. Show that a centimeter square, the total area of the thin sheet metal is metal used is given by this. So we have to the surface area, show this the total area of the thin sheet metal. The surface area is given like this. Secondly, given that x and y can vary, find the stationary value of a and determine its nature. So this is the part of problem that we are going to solve. So Let's start this. We have this kind of structure. This is open area. This is the container, empty container, triangular prism shape. Volume of the container is given as 200 under 3 centimeter cube. The area of the equilateral triangle is h x square minus x upon 2. So this is h. H is this. This is the height. So height is basically given by this is x. This value is x. So this value is from here to here is x by 2. So this is height. So h is equal to x square minus it. By using Pythagoras theorem, this square is equal to this square. So h is equal to this square minus this square. So this is h is equal to this x square this. So this is 3 by 2x. So this 3 by 2x is obtained. This is the height, and now the area of equilateral triangle. This is 2 times half this area. So this area, and the other part is the other area. So we have this 2 times of this area, this quadrilateral area, this area. It may be solved like this. So we have this equal area. So this is twice of this is equal to this height into x by 2 into y. This is the length. So this is equals to volume. So this is basically the volume, height, this length, and this area multiply with the height. So area multiply with the height gives the total volume. So this volume is obtained, and this volume is equals to 200 under root 3. So as a result, this values, this is the height. For this side or this side, they have an equal. This height is the same. So this height, this so this is the triangle area is given by this, and this length height is multiplied to get the volume. So this is the surface area. This is the area that we have obtained by this one, and this is the length of volume. So this is volume, and this twice to get the double area, because we have right angle triangle. So this right angle triangle, so this double area, so it becomes this. So x square upon this. So y is equal to 800 by x square. So this was obtained, and then from two triangles, this is basically this area and the rectangle. So there are two triangles. On this side we have this triangle at this side, and the other side triangle on this side, and this is a true two areas. So this is two rectangle, this rectangle and this rectangle, this triangle and this triangle. So this triangle and two rectangles. So we place this value. So this is the two triangles and this two triangles. So when simplifying, we get this one. So 2 times rectangle and 2 times triangle. We have under root 3 divided by 2 x square. So this is 1600. This x divided by this x. So this is the area. So we have shown this, and it was the requirement. And now we take the derivative of this with respect to x to get the stationary point. So here we have this equal to 0. Under root 3x is equal to 16. So this under 3x is equal to 16 by x square. So this will multiply here, and this will denominator. So this x cube is given as 9.74 x. So we place this value in place of x to get the area, and that is obtained as 246.426. So this is the area, and now we take the derivatives. So we see that this is greater than 0, So the area is minimum at x equal to 7. So whatever the value we substitute, we get this area is positive. So this is positive means this is increasing. So the stationary point is the minimum value. So this was the requirement. So this is the last problems. These are the very practical problems that we have discussed here. So next time we'll discuss the other chapters. So this is very, very important.